As Richard Feynman said, quantum electrodynamics is the jewel of physics because of its extremely accurate predictions. From quantum electrodynamics, we know that the forces acting between two particles are carried by certain particles called as virtual particle. If you want to know more about them, then watch my video on it. Link is in iCard and in description too. But the only field whose carrier is not known is gravitational field. We assume an hypothetical particle, graviton, as its carrier, but there is no experimental proof of it. Graviton plays a very crucial role in both quantum mechanics and general relativity. It is the only link which can combine both these independent branches of physics. Lots of theories as a candidate of quantum gravity are proposed in regard to unify these two branches, but among them, few theories are highly underrated. I think we should know about those theories if we can do something. So today's topic is on superfluid vacuum theory or Bose-Einstein condensate vacuum theory. Earlier, it was believed that our space contains luminiferous ether as a medium through which electromagnetic waves flow. But advent of the special theory of relativity discarded this concept and we considered this space as a vacuum. But as per quantum mechanics, we know that this space is not empty. All the time, virtual particles came into existence and pairized themselves. As per Paul Dirac, we should take into account these quantum fluctuations in the flow of the ether. His argument involves the application of the uncertainty principle to the velocity of ether. We can't find the velocity of this ether with accuracy, thus we should represent this ether by a wave function. But what composed this superfluid? As inspired by Dirac ideas, three physicists K.P. Sinha, C. Sivaram, and E. Sudarshan published a paper in 1975 suggesting a new model of ether, according to which this superfluid is composed of fermion and antifermion pairs, describable by a macroscopic wave function. A recent study compared astrophysical observations with predictions based on the notion of fluid spacetime and found that the idea only works if spacetime is incredibly smooth and freely flowing. In other words, a superfluid. Physicists focused on the photon particles traveling through spacetime from Crab Nebula, like waves in an ocean, then applied the laws of fluid mechanics. So theoretically, physicists considered that the particles with different energies would disperse in spacetime as waves disperse in water. However, the experimental observations shows no sign of dispersion in photons energy. But it doesn't mean that this idea is completely wrong. It can also happen that the viscosity of space-time fluid is very low, because of which we can call this fluid as superfluid. Let's understand this from the mathematical point of view. How the movement of particles in space-time vacuum can be regarded as a flow in a fluid space-time. As in fluid, the speed equation is given by this. So we will derive how a flow of particles in a space-time can be represented as by this speed equation. Consider two particles traveling in a space. First particle moving with a constant velocity v much less than velocity of light, and another particle moving with velocity smaller than or equal to speed of light. Then their momentum is this. Hence total momentum becomes this. Now total energy is E equals integration F dot ds, where from Newton's second law force becomes dp by dt. Further equation reduces to integration v dot dp. Since at speed of light mass is not constant, thus differentiating momentum and putting its value in equation 3. Further differentiating with respect to v, equation becomes as shown, where mv is momentum of particle 2 and its difference from total momentum is equal to momentum of particle 1. Further integrating with appropriate limits and putting the value of momentum of particle 1, we get m equals m naught 1 minus v by c. So, by putting this value in equation 3, we get E equals minus m naught c square by 6. This energy equation defines the amount of mass that get converted to negative mass when any particle is traveling at light speed. To derive space-time of fluid, now consider a small imaginary cubical structure in space-time with area dA and height ds. If space-time is a fluid, it must have mass, which can be expressed from equation 4. On differentiating both sides, we finally get this. Putting value of energy from equation 5 and further calculating, we finally get dP by d rho equals 6c square, where 6 can be neglected as proportionality constant. Thus, equation 6 is identical to equation 1, which clearly signifies that the wave propagates at a light speed in spacetime, and spacetime behaves as a fluid medium. Still, this theory requires lots of research. There are many physical phenomena which can't be explained by this theory, but I hope in future it will disclose more mysteries of this universe. So, at last, please don't go without liking this video, and please give me your feedback regarding my narration or comment me if you have any questions. And please subscribe my channel. So, at last, thank you for watching.